In this video, we are going to walk through how to find the acceleration of a block that is placed on an inclined plane. So let's jump right into an example. This says, a block with a mass of 2 kilograms is placed on a frictionless plane, inclined to the horizontal at an angle of 15 degrees. Find the acceleration of the block down the plane. So I've sketched out this situation where we have this inclined plane where the angle relative to the horizontal is 15 degrees, and we have this 2 kilogram block that we have placed on this plane. Now, we know the block is going to slide down the plane, but we want to know what will be the acceleration of the block down the plane. So how can we find that? Well, the first thing that we have to recognize is that there will be a force of gravity working directly downwards on this block. And this force of gravity is simply going to be equal to the mass of the block times gravity. So we'll say m times g. Now, when we have this force like this, we can actually break this down into two components, where one component will be the force that is directly perpendicular to the inclined plane, and the other component will be the force that is directly parallel to the inclined plane. Now, when we draw these components like this, it's important to recognize that this angle right here is going to be the exact same angle as this angle. So this will also be 15 degrees. Now, why is that? Well, if you notice right here, we have a right triangle, where this angle right here is exactly 90 degrees. And one thing that we know about triangles is that all three angles of a triangle must add up to 180 degrees. So if this is 90 and this is 15, 90 plus 15 is 105. This missing angle right here, this must be 75 degrees in order for these three to add up to 180. And another thing that we'll notice is that this angle right here is also 90 degrees. So if we know that this is 75, then this angle right here, this missing angle, must be 15 in order for these two to add up to 90 degrees. So that's why this angle is the same as this angle. Okay, now that we've established that, our next question is, what's the magnitude of these two forces, of these two components that we just drew? Well, we know that if we add these two forces together, they will equal m times g. So this force right here that's perpendicular to the inclined plane, this is going to be equal to mg times the cosine of this angle, 15 degrees. Now, why is that? Well, notice that if we draw a little line right here, what we have here is another right triangle. And in this case, we are interested in finding the length of this side of the triangle. So let's just call this x temporarily. If you think back to trigonometry, if you remember the acronym SOHCAHTOA, the C tells us that the cosine of an angle must be equal to the adjacent side of the right triangle divided by the hypotenuse of the triangle. So in this right triangle here, this is the hypotenuse, and this would be the adjacent side to the 15-degree angle. So what we could say is that the cosine of this angle, let's write that down, the cosine of 15 degrees, it must be equal to this adjacent side, which we're temporarily calling x, divided by the magnitude of the hypotenuse, which we already know is m times g. So mg. So to find this x right here, this missing side length, we would simply multiply both sides by mg. So we'd find that x is equal to m times g times the cosine of 15 degrees. So that's where that value comes from. Now this force, the one that is parallel to the inclined plane, the value of that is going to be m times g times the sine of 15 degrees. And why is that? Well, again, if we remember this right triangle that we formed right here, SOHCAHTOA tells us to find the sine of an angle, you take the length of the opposite side of the triangle and divide it by the hypotenuse. So in this case, the opposite side would be this side right here, let's call that x, divided by the hypotenuse, which is mg. So what we would have is the sine of 15 degrees is equal to, remember, let's just call this side x temporarily, x divided by the hypotenuse is mg. So to solve for x, we would just multiply both sides by mg. So we'd find that x is equal to m times g times the sine of 15 degrees. So that's what the magnitude of this vector is right here, which is the same as this vector that's parallel to the inclined plane. So that's where that value comes from. Okay, so the last thing we need to realize is that Newton's third law of motion says that there will be an equal and opposite force to this perpendicular force right here acting on this block, and we call that the normal force. Now, this normal force is going to be the exact same as this force right here. So these two forces are actually going to cancel each other out. And what we'll find is that the only force working on this block is this value right here. So what we can say is that the net force, let's say F net, the net force working on this block is simply going to be equal to this value right here. So mass times gravity times the sine of 15 degrees. And Newton's second law of motion tells us that the net force of an object is simply equal to the mass times the acceleration. So we'll say equals m times a. So notice that this is our final equation that we have to solve for a, and that will tell us the acceleration of the block. So what we'll notice is that there's an m on each side, so these m's cancel out. We're left with a, let's write it on the left-hand side, a is equal to g times the sine of 15 degrees. Now g, that's the magnitude of gravity, which is just 9.8. So we get 9.8 times the sine of 15 degrees. And if you punch this into a calculator and make sure your calculator is in degree mode, that comes out to about 2.54. And we're talking about acceleration, so we'll say meters per second squared is our units. Now, when we're talking about acceleration, we should also specify the direction. So in this case, we'll say down the incline. That's the acceleration of the block down the incline. So that will be our final answer for this one. So that's how you can find the acceleration of a block that is placed on an inclined plane.